relative velocity in terms of position time graph. So this is pretty helpful. So we will go case by case. So I'll take up the case of when the object have the same velocity. Remember, the velocity is same. So both the magnitude and direction is same. So basically, let me show a case. You have one car and you have another car. Both are moving at 40 kilometers per hour. And they are moving in a straight line. Okay, so this is a straight road somewhere in a desert. So this is very straight for at least say 4 kilometers. Now, if the gap between them happens to be, say there's some decent gap of say 20 meters. After say 30 minutes, if the speed is not changing, what will happen? Provided nothing else change, the speed does not change and the road is the same. What happens? It will remain the same, right? The distance or the gap between them will not change. So what will be the position time graph for this? Position of car 2 or car B with respect to car A. Yes, position of car B with respect to car A. We'll consider this as B and this is A. Yes, it is 20. And this will not change. This will be 20 meters. The gap will be 20 meters. Considering this as positive direction, that would be the case, as simple as that. Right? Now, we have velocity 1 greater than velocity 2. So we have a car, right? So your car, you are in that car, and this is another car. This is V2 and this is V1. What happens? Same thing. Or let me copy this actually. That will make more sense. Same picture. Do I have it? Yeah, I do have it. But in this case, this is say 80. Okay, so this is I'll call it as A and this is B. That's convenient for me now. And this is a lot more velocity than this. So what will happen after say some amount of time, say X minutes? What will happen? If the speed does not change, will it be the same? Yes, the gap between these two vehicle will reduce. It would be so, and it will pass. Agree? So it will reduce basically. So it won't be 20 anymore. It will be say 10. You guys agree? So what's happening? The distance between them reduces and then, yes, it increases. If I take right as positive direction, can you guys draw the graph for this? Draw the position time graph. Position of car A with respect to B. And this is time. So initially the position is to the left. So it is what? It is negative and it is 20. It's 20 meters away. And eventually what will happen? It will close to 0. And once after post that, car will overtake and it will increase in this manner. Right? So this is back of car B passing car B, and this is ahead of car B. Okay, I've written car B over there. So yeah. Okay, guys. As simple as that. You guys agree? Provided everything else remains the same, there is no acceleration and stuff like that, this will be your position time graph. And finally, the third case, I don't want that, I want this. Still, I just can copy all of this. Now the case is, the object is slower than this is the case. So I have not written which is A and which is B, my bad. So I need to mention that this is A and this is B. A with respect to B. Yeah, perfect. So that's A and this is B. Now this is much smaller. Say this is 8 and this is 40. Now the question is what will happen? So in time, the vehicle will go away. Do you guys agree? So what will happen to the gap between them? Again, all this is commonsensical. What will happen to the gap? It will increase. So it will be say 30 meters after some time. So it will increase. So how will the position time graph look like? So position of vehicle B position of B with respect to A. So to begin with, there was a gap of 20. And remember, left is negative. So I'm looking at negative 20. And after that, what will happen? It will increase. And again, remember, left is negative. So it will increase this way. So that would be your graph. If the vehicle was overtaking, right, then this would have been your graph. This is where the car A overtakes car B. This is for case, not this case, separate case. Case when car A overtakes car B. This is the actual case. So the gap will keep increasing and so on and so forth. I think I did all of it. Yeah. Okay, so if you are able to understand whatever we discussed till now, yeah, it's done.